So last lesson we were given that segments are parallel, but we could also be asked to prove that segments are parallel. So when we are asked to prove segments are parallel, what we want to do is find a pair of triangles that are congruent and then use CPCTC, or corresponding parts of congruent triangles, are congruent to prove that a pair of alternate interior angles are congruent. It doesn't necessarily have to be alternate interior angles. It could also be exterior or corresponding, but you're going to find that most of the time it is interior angles, and that's probably the easiest to see. And then what we could state is that if two lines cut by a transversal form congruent alternate interior angles, then the lines are parallel. So it's really just the converse of the statement we learned the other day. So let's take a look at an example here. So we are given that n is the midpoint of LP, LP bisects MO. We want to prove that LM is parallel to PO. Okay, so let's maybe mark up our diagram and make a plan, and then we can go ahead and write out our proof. So our goal is to really show that alternate interior angles are congruent. If alternate interior angles are congruent, then that means that the lines have to be parallel. So if we want to prove that LM, whoops, that was terrible. If we want to prove that LM is parallel to OP, well, we could pick any transversal here, either LP or MO. I'll just pick this one here. So I'm going to pick this transversal. I need to show then that this angle and this angle are congruent, because these are alternate interior angles. If these are congruent, then the lines are parallel. So I need to somehow get this angle and this angle by using CPCTC. So I think you could probably, there's only two triangles here. So it's going to be this, we're going to prove this triangle to be congruent to this triangle. And then we'll use CPCTC. So let's mark off our diagram here. Okay, we have N is the midpoint of LP, so that must mean that LN and NP are congruent, because a midpoint divides a segment into two congruent segments. Then we also have that LP, so this line bisects or cuts in half MO. So if it cuts in half MO, this and this would be congruent. Okay, we only have two pieces. We only have this side and this side. Remember, we want to get these blue angles. We don't have them yet. We need to somehow prove the triangle's congruent first. So we don't have these, so we can't say use that in our proof here. We're out of givens, but you'll notice that there are vertical angles right here. And then we can go ahead and prove the triangle's congruent by side, angle, side. Once we prove these triangles congruent by side, angle, side, we'll use CPCTC to say angle M is congruent to angle O. And there we go. We have our alternate interior angles congruent, so that must mean that the lines are parallel. So now that we made our plan, let's go ahead and write out our proof. And as we write it out, I'm going to highlight the markings to just show that we went ahead and completed it. So we have N is the midpoint of LP. Given, well, that gives us that LN is congruent to PN, because a midpoint divides a segment into two congruent segments. Next, we have that LP bisects MO, and we know a bisector divides a segment into two congruent segments, so that gives us this and this. Okay, at that point we were out of givens, but we realized that we had vertical angles right here. So we can go ahead and say that LNM is congruent to angle PNO, because intersecting lines form congruent vertical angles. At that point, we had enough information to go ahead and prove the triangle's congruent by side, angle, side. So triangle LNM is congruent to triangle PNO by the side, angle, side method. And then the reason why we did this was because we wanted to go ahead, in order to prove that these lines are parallel, so in order to prove that this line and this line were parallel, we had to show that the alternate interior angles were congruent. Well, since those triangles are congruent, that means all their corresponding pieces are congruent. So therefore, angle M has to be congruent to angle O because of CPCTC. So this angle and this angle are congruent by CPCTC. If we wanted to, we could have, we could have went ahead and did this transversal instead, so I'll do it in green. We could have picked this transversal and instead picked angles L and P. They're both alternate interior angles, so it didn't matter. In our markup, in our plan, we went ahead and did M and O, so that's by CPCTC. So since they're alternate interior angles and since they're congruent, well, then the lines have to be parallel. And our saying for that is, if two lines cut by a transversal form congruent alternate interior angles, then the lines are parallel.